All right, so get this.
Okay.
A binary star system.
Wow.
Two stars, basically just dancing around each other,
Yeah.
have been found right next to our galaxy's supermassive black hole.
Oh, wow.
It's like finding a hummingbird nest in a hurricane.
That's wild.
I mean, it's pretty crazy.
Yeah.
So we're going to be going deep on this discovery today, using a recent scientific paper to guide us.
Awesome. This is going to be fun.
Yeah, so tell us a little bit about this.
It's called D9.
D9, okay.
And it's basically nestled right in the heart of the S star cluster.
Okay.
It's a really chaotic swarm of stars orbiting Sagittarius A, which is the supermassive black hole at the center of our galaxy.
Gotcha.
You wouldn't expect anything delicate to survive there.
Yeah, I mean, it's
yeah.
pretty intense environment.
Incredibly intense.
So why is this such a big deal?
Oh, okay. So
I thought stars formed all the time, even in crazy places.
like Sagittarius A, or SGRA, as it's often called. It just throws a massive gravitational wrench into things.
Yeah.
Like you can't even imagine.
Yeah.
And astronomers have long believed that those intense forces and the breakneck speeds near a black hole like this would just rip apart any binary system trying to form.
Yeah. No, that makes sense.
Yeah.
So it makes this pretty much impossible.
Yeah. They thought it was impossible.
Wow. Okay. I'm starting to see why this is raising eyebrows in the astronomy world.
I mean, it really is.
It's like finding a perfectly formed snowflake in a blast furnace.
Yeah.
It just shouldn't happen.
So how did they even find this D9?
So
Was it hiding behind the black hole or something?
it's more like it was masked by our own methods.
Okay.
Previous studies would combine multiple observations of the S cluster, and that kind of smoothed out the subtle movements of D9.
Okay.
But this time, researchers actually analyzed each night's observations individually.
So they broke it down and then were able to see it more clearly.
Exactly. So by breaking down the data, they could actually see the wobble that signals a binary system.
Yeah, like you said, they broke down the data and they were able to see that telltale wobble.
Gotcha.
It's like figuring out a complex dance move by slowing down the music and focusing on each individual step.
I like that analogy.
Yeah.
That's a good one.
And you know what's even more fascinating?
What's that?
Is that this discovery really challenges our understanding of how stars form near supermassive black holes.
I remember reading that the stars in the S cluster are younger than scientists initially predicted.
Right.
Could this be connected at all?
I mean, that's one of the big questions this discovery raises.
Okay.
One theory is that D9 might not have even formed right next to the black hole.
Okay.
Perhaps it formed further out where things are a little bit calmer and then migrated inward over time.
So the black hole's gravity kind of acted like a magnet
Yes.
and pulled in the star system.
It's very possible.
That's so cool.
Yeah, and that could explain why we see these unexpectedly young stars hanging out so close to Sagittarius A.
Yeah.
They weren't born there.
Yeah.
They moved in.
They just moved in?
Yeah.
Wow.
And you know, if this migration theory holds up, it could rewrite what we know about how star clusters evolve near galactic centers.
That's huge.
It's a big deal. Think about the implications.
Yeah.
We might be seeing like a universal mechanism for star cluster evolution playing out right before our eyes.
Yeah, and I mean, if it's happening in our galaxy, could it be happening in other supermassive black holes
Of course.
throughout the universe?
Yeah, that's the question astronomers are now grappling with.
Wow.
And the answer could fundamentally change our understanding of galaxy evolution on a cosmic scale.
That's insane.
It's pretty crazy.
Okay, so before we go too far into that, let's talk a little bit more about D9 itself.
Okay.
So you mentioned earlier that this binary system is on a collision course. What happens when two stars decide to merge right next to a supermassive black hole?
Well, that's where things get really interesting and potentially explosive.
Ooh.
But before we get to the fireworks, I think it's important to understand what we know about D9 so far.
Okay, let's unpack that.
Okay.
What makes this particular binary system so unique?
Well, first of all, it's the first binary system ever found this close to a supermassive black hole.
Okay.
We knew of 5 other binary systems near SGRA, but they're all much farther out, orbiting in a calmer region.
So this one's like right up.
Right on the edge.
Yeah, like the daredevil.
Yeah, it's like the daredevil of the S cluster.
Of the group.
Pushing the limits.
Pushing the limits of what we thought was possible.
Exactly.
Okay, I'm already hooked.
Good.
Tell me more about its cosmic daredevil.
Okay, so D9's proximity to the black hole means it's constantly being tugged and stretched by these immense gravitational forces.
Yeah.
It's like a ship navigating a cosmic whirlpool.
I can only imagine the stress those two stars are under.
Oh, yeah.
Do we know anything about the stars themselves?
Yeah.
Are they similar to our sun?
They're actually quite different from our sun.
Okay.
They're both what we call main sequence stars.
Okay.
Meaning they're still fusing hydrogen into helium in their cores.
Gotcha.
But that's where the similarities end.
Okay, lay it on me. What kind of stars are we dealing with here?
So one of the stars in D9 is a B-type star.
Okay.
Much hotter and more massive than our sun.
Uh-huh.
It's the type of star that shines with a brilliant blue-white light.
Wow.
The other star is a bit smaller and cooler, likely an A-type star.
So it's a bit of an odd couple.
Yeah.
A cosmic hothead paired with a cooler companion.
You got it.
I'm guessing that makes their relationship pretty intense.
Oh, yeah.
Especially with a black hole trying to pull them apart.
For sure. You could say that their orbits are incredibly tight and fast. They're whipping around each other at speeds. That would make a fighter jet look like it's standing still.
Hold on, rewind a second.
Okay.
Didn't we say earlier that D9 might have formed further out from the black hole?
We did, yeah.
And migrated inward?
Right.
How does that square with this idea of them being in a tight, fast orbit?
Yeah.
Wouldn't the black hole's gravity have stretched out their orbit?
Right.
Making it more elongated?
You would think so,
Yeah.
and that's a great point.
Yeah.
It highlights one of the fascinating paradoxes of orbital dynamics near a black hole.
Okay.
While you might expect the black hole's gravity to pull things apart, it can also have the opposite effect.
Okay, now I'm really intrigued.
Okay.
How does a black hole act like a cosmic matchmaker?
Well, as a binary system, like D9 migrates inward,
Okay.
the black hole's gravitational influence can actually cause the star's orbits to shrink and become more circular.
So it brings them closer together.
It does, yeah. And this is because of something called tidal forces.
Tidal forces. Isn't that what causes the ocean tides here on Earth?
That's right.
Oh, wow.
Tidal forces arise because gravity's pull is stronger on the side of an object that's closer to the source of gravity. In the case of D9, the black hole's gravity pulls more strongly on the star that's closer to it.
Gotcha.
Which can have the effect of squeezing the orbit.
So the black hole isn't just pulling on the stars individually.
Right.
It's also shaping their relationship with each other.
Exactly.
Fascinating.
And this tidal squeezing effect is thought to play a key role in the evolution of binary systems near supermassive black holes. In fact, it's one of the reasons why astronomers believe that D9 is on a collision course.
Right. We keep talking about this merger, this cosmic collision.
Right.
But what does that actually mean for D9?
Yeah.
What happens when these two stars finally meet their fate?
Well, it's not going to be a gentle embrace.
Okay.
When two stars collide, it's a cataclysmic event that releases an enormous amount of energy.
I'm picturing a cosmic explosion.
Yeah.
A burst of light that would outshine entire galaxies.
You're not far off.
Okay.
The exact details of the merger will depend on a lot of factors, but we can expect a dramatic increase in brightness, a surge of radiation across the electromagnetic spectrum, and possibly even the ejection of material at near the speed of light.
Wow. Talk about a front row seat to a cosmic fireworks show.
It would be incredible.
But hold on.
Yeah.
If this merger is going to be so bright and energetic,
right,
won't it be hard to miss?
Yeah, that's a good question.
I mean, wouldn't we have already seen signs of it happening?
That's where the timescale of these events comes into play.
Okay.
While we might think of a stellar merger as happening in an instant, it's actually a process that can unfold over thousands, even millions of years.
So it's more like a slow-motion explosion.
Exactly.
A cosmic ballet rather than a sudden bang.
That's a good way to put it. And while we might not see the merger itself happen in our lifetimes, we can still observe the stars as they spiral closer and closer together, studying their interactions and learning valuable information about stellar evolution in this extreme environment.
It's like watching a cosmic train wreck in slow motion.
Yeah.
Knowing the inevitable collision is coming, but wanting to study every detail leading up to it.
That's a rather dramatic way to put it, but you're not wrong. And the data we collect from D9 in these final stages could be even more valuable than the discovery itself.
Okay, I'm on board with the scientific value of this cosmic train wreck.
Okay.
But I can't help but feel a bit of, well, cosmic dread for
Yeah.
these two stars.
Yeah.
It's like watching a Shakespearean tragedy unfold.
Yeah.
What will happen to them after they merge?
That's a great question.
Yeah.
Will they form a new, even bigger star?
Right.
That's a great question, and it leads us to one of the most exciting possibilities.
Don't leave me hanging. What is it?
Right.
All right, you've got me on the edge of my seat. What happens to these stars after they merge?
Well, as dramatic as this merger sounds, remember, these stars are already quite massive, and their combined mass, even after the energy released during the merger, might still be large enough to form something truly extraordinary.
You're not suggesting they could form a black hole, are you?
It's not as far-fetched as it sounds.
Right here in our own galaxy.
We know that supermassive black holes lurk at the centers of galaxies, but stellar mass black holes, those born from the deaths of giant stars, are scattered throughout.
Okay.
So if D9's merger results in a black hole, it wouldn't be supermassive, but it would be a rare chance to witness the birth of one of these cosmic enigmas from start to finish.
Okay, my mind is officially blown. So we could be watching a black hole being born right now.
It's possible.
It changes everything. Instead of just a cosmic train wreck, we're talking about a cosmic creation event.
It really is.
Yeah.
And think about the scientific value of that. Yeah.
Right now, we have theoretical models of how stars collapse into black holes.
Right.
But actually observing the process.
Yeah.
That would be a game changer for astrophysics.
It's like having a front row seat to the universe rewriting its own rule book. But how would we even know?
Whoa.
What would we see if a black hole formed from D9's merger?
It wouldn't be a sudden flash of darkness.
Yeah.
Instead, we'd likely see a powerful burst of X-rays and gamma rays as the newly formed black hole starts gobbling up surrounding material.
Yeah.
And the black hole's intense gravity would warp the fabric of space-time around it,
Right.
creating observable effects on nearby stars and light passing by.
So even though we can't see a black hole directly, we could detect its presence through its influence on its surroundings.
Exactly. It's like knowing a cat is in the room because you see the curtains rustling, even if the cat itself is hiding.
I like that analogy. It's a good one. And that brings us back to the wider implications of this discovery.
Yeah. Right. We started by talking about D9 challenging our understanding of star formation near supermassive black holes.
Right.
And now it's potentially challenging our understanding of black hole formation itself.
It really is.
Is there anything this little binary system isn't teaching us?
I know, it's incredible. What's fascinating is that D9 might not be unique.
Okay.
If binary systems like this can form and migrate inward towards the galactic center, then it's possible this is a common process shaping the evolution of galaxies throughout the universe.
So those supermassive black holes we find at the heart of most galaxies might be fueled, at least in part, by a steady stream of stars and gas delivered by migrating binary systems like D9.
It's a compelling theory, and one that future observations of other galaxies will help us test.
Wow.
But for now, D9 remains our closest, most detailed look at this incredible cosmic dance.
I feel like we've barely scratched the surface of this discovery.
Yeah, me too.
It sparked so many new questions.
So many.
And avenues for research. What are you most excited to see unfold as we continue to study D9?
For me, it's the anticipation of the unknown. Will D9 merge in a spectacular burst of energy, leaving behind a newly formed black hole?
Right.
Or will it surprise us with something we haven't even imagined?
Exciting.
That's the beauty of science.
Yeah.
The universe is full of surprises, and discoveries like this remind us that we still have so much to learn.
Well said. This has been an incredible deep dive.
It has.
And I have a feeling we'll be revisiting D9's story in the years to come.
I think so, too.
As new data emerges. For our listeners who want to delve deeper into this discovery, be sure to check out the links to the scientific paper and supporting materials in the show notes.
Yeah, good idea. And as always, keep looking up. Keep asking questions. And never stop exploring the wonders of the cosmos.
Thanks for joining us on The Deep Dive. Until next time.